Let me just take this over, and what I'm going to go over now next is, first of all, I will be reviewing what is trust over IP, because it's one of the key components in my mind on the future of digital identity as a whole, because you can think of identity as just technical development or as technical and governance and as a meta model. So there's a lot of different aspects to think from. So I'll be looking at this. I will be showing a lot of different types of information. So please bear with me. And if you're interested in any of those, I can give you links. I can give you the material directly. So no worries. If you miss something, you can have it. And yeah, so then at the end, I'm going to be also reviewing the assignments that are to be given to you. And yeah, I think that's it. So let's get on with this. So thanks, Markus. And Markus went deeper into what Finde is. And what I want to show next is the generics of what is sort of the whole big picture when it comes to digital identity transactions or interactions or what have you. So things that happen behind when you do things like in the future, like proving your identity or showing your driver's license or giving consent or something like this. And this is by not all means not comprehensive, but an example, and pardon the poor picture, but I'm trying just to give sort of first the complexity of what the whole identity actually has in the background. So if we look at an identity transaction, and as an identity transaction, I mean that anything in the future, when you give a credential, you give a proof or a credential between a person and an organization, or even person and person, there's a lot of things that have to do into making it secure, making it authentic, making it verifiable, etc. So, for example, within an identity transaction, you will have wallets. You've heard that. We will have mobile digital wallet for a person. In future devices, it may be something else. Let's say in metaverse, if you're using VR, you all already have a device there that can act as a wallet. So in that wallet, you need things like identifiers. And I'm not talking about the personal ID that we've had so far in Finland. That's a unique individual identifier. I'm talking more about identifiers that you use to provide to others, so they can know who you are and how you can bind your credentials to those identifiers. So, but they're not unique in the sense that, or they're not unique that you would use the same identifier all over again. No, but you would generate one for each transaction. You have those cryptographic keys we've been talking, those credentials that you actually share. That's one type of information. You may have biometric binding through the device, irises or fingerprints or face or what have you. You may need that for a wallet, and you use that already on a daily basis. Device binding as well, that the other side would know that this doesn't come from an unreliable device. On the organization's end, you would have an enterprise agent or a wallet or an application. You would have those same things likely, not necessarily biometric binding because of the organizational rules, but more about privileged access management. So you'd have credentials given by IT admin in an organization. And the transaction itself needs a lot of things. It needs a protocol to register wallets. So not all wallets are created equal, unfortunately. There will be some that will be much more, let's say, trustworthy than others, mainly because they put so much effort into ensuring that there's no fraud. There will be requirements for certain types of wallets, especially when it comes to EU. That's critical. Root identity anchoring, things like where do you get your root identity? So if Gabby says that I'm Antti, you just trust Gabby. I don't think, let's say, a bank would trust Gabby to say that I'm Antti Kettunen. No, they would trust the Finnish authorities to do that. So that's root identity anchoring. You have credential issuing protocols, different kind of technical protocols to issue those credentials and present those proofs. You will have different kinds of credential formats. You have semantics for the data that deals with the content of the credentials. Then you have cryptographic mechanisms, encryptions, signatures. You have the way to create the connections, the messaging protocols or the transportation protocols like Bluetooth and NFCs and HTTP, et cetera, et cetera. And the data exchange format, basically in what format that data is to be exchanged, so it can be encrypted, so that it could be signed, so it could be used in different types of transportation formats, etc. And then you need things like trust frameworks, trust infrastructures, like FINDI type of infrastructures, where you need key verification registries or revocation registries, etc. And all of this then is used by ecosystems, where you can use different types of ecosystems, whether it's just within, let's say, a few banks or within financial industry only, or whether it's like fully in Finland for certain common credentials or whatnot. So this picture, however poor it is in visually, it just tries to explain a little bit of the complexity. If you take an app from your app store, whether it's for phone, whether it's for your Macs or Windows or Linuxes, it's all contained within that app. Granted, they will have interfaces and APIs, but they're usually, most of the time, they are custom built, or they're based on some very, very specific and important systems. Like in Finland, what we do, we have certain APIs that are used by many organizations, whether they're from PRH or DVV. So, but they're usually then coming from these high authorities like governments. But in order to create an ecosystem application or a service, and imagine that you have all of this to agree on, that becomes difficult, because if something is difficult, it's agreeing on something between organizations and service providers, because everybody has their own thing. Everybody wants to do their own thing. They have their own benefits and their sort of viewpoints into what type of approach would need to be done. So the complexity of SSI really is there, and I've created, and I'm currently continuing to create this kind of a conceptual model. It's still relatively early stages, but tries to capture most of the in this conceptual model, the bits and pieces of what goes into identity transaction. You can see here we have the issuer, the holder, and the verifier, and we have the ability to use a mobile wallet and create connections, and then describe that within the connection that's formed, it's formed through a transportation protocol that uses a messaging protocol, and you have digital signatures, credential formats, data exchange formats, and you have different types of standards and specifications that you need to consider, and all of these have their own benefits. All of them have their own pros and cons. And when it comes down to verification and you getting a proof of, let's say, identity at some point, you need to somehow attach it to a business service, whatever that business application behind it is. So this is just, I'm not going to go over this. This goes much more technical than most of you want, definitely. But just to make you aware that this is available, I've shared it in GitHub, and I will be working on this later on, and I will be referencing this. But this is just to highlight the complexity. And for that purpose, to lessen the complexity and simplify it, we usually use frameworks or meta models to make everybody understand why and how they should be using this. And trust over IP is really about that. It's about defining an architecture for internet scale digital trust. And it combines the technical bits, the cryptographic verifiabilities, the machine readable things, with the human accountability things that include business, legal, and even social layers in some cases. So it was started a couple of years ago by 27 original members. Today, over 300 organizations, over 100 individual members. It's under Linux Foundation. And what we do is we work in working groups, and we're really self-organized through the community. So there's not one party that says that this is what you need to do. This is fully organized by the community itself. So I'm personally there. I am a co-editor in the technology architecture and trust registry task forces. So I'm deeply involved in this, and I'm really putting my all. But just to give you the picture of what is the trust over IP, what are we solving? So it's really about, as I mentioned, it's about bridging the gap between the technical side, the complexity that I showed, with the governance side. So you have the triangle here, a traditional triangle where you have paper or plastic documents and displaying those documents, like we have our driver's licenses today. And the trust comes not from the fact that you trust the issuer itself, but the governance authority that you understand that ensures that this is a proper document. Whether it's, let's say, the e-receipt or the receipt that was mentioned. If you get a receipt, you may actually trust the issuer, but what if that receipt is just a scam receipt? So they're just writing you receipts, and it's actually not a receipt. So when you go tax administration, you want to present it to something, you may have problems. So there is always a governance authority that is behind those issuers. So you know that the issuer who issued you the document is trustworthy. That doesn't come from you trusting the organization. It comes from you trusting the governance behind that. And the governance framework is published and utilized by the governance authority and the issuers within that, and sometimes the verifiers as well. So this, in a digital format, is what trust over IP is. It's about bridging the gaps between the technology and the governance parts. So you can see that then that the same thing would happen in different kinds of environments. Whether here on the left side is the banking environment, let's say in US, credit unions are using this. Finland is a little bit different, Nordics is a little bit different, but still the same idea applies here, is that we have banks that issue credit cards. You are a credit holder, and you're maybe using Apple Pay or Google Pay to do the pay in merchant services. And the point of the merchant is that they don't only trust the bank, but they trust the behind of that. There's a credit card institution or a credit union institution that handles the governance framework. So there's always that. And the same thing, let's say in government, Canadian federal and provincial governments have the same thing, that government service is offering the driver's license, and then the citizen can share that to different relying services, because they know that there is they can check the governance behind the credential. And as said, that I think I answered this in somebody's question, is that this is really the key. The Finland, it sounds simple. We've had this for a long time, but not all have this. Canada is divided into federal government and provincial governments, which all have their own responsibilities. So even if federal government does something, it does not mean that provincial governments are actually applying it, or vice versa. That if one province does something, that other provinces do it. And so in Finland, it's really about enabling interoperability, not only in Finland, but also across globally, across nations. And for us, it's then also about enabling new types of services and new kinds of service models that don't rely only on those centralized services that currently we're very dependent on. So the trust over IP model, the dual stack model, this is the model, and I'm briefly going to go over it and then moving forward. But this is, I think, a very good framework for viewing any kind of self-sovereign identity models. This is a very generic model. The layer one at the bottom, deals with the trust support or utilities. And what it essentially means is that when we need something like blockchain or even a centralized services to verify key authenticity, verify the validity of cryptographic keys, for example. That's the place where we go to. Anything that is common, that is available for everybody, should be here on layer 1. Layer 2 is about connecting wallets. And as Markus said, that there's separation from the utility layer, the common good for everybody, and the wallet layer, which is layer 2, where we actually have the wallets enabling connections between each other. So this is an area where we already have service providers providing their services for wallets. So it's already a half competitive area. But if we would all work on this independently, we would have no interoperability, meaning we don't have those value chains of issuer, holder, verifier. We will just have the value chain that each wallet provider can provide. So that's why what we want to enable is that there is an interoperable and open way for these wallets to communicate so that they don't need to form their own ecosystems. They can just focus on building their wallets. That's it. And they will have their own governance frameworks. And Findi is going to be one of those, obviously, that they're going to be creating for the Findi ecosystem in Finland, these wallet governance frameworks. And so these are basically contracts that state that wallets are compatible with certain things or etc. So, and then on the layer 3, what we call trust tasks. So this is a generic model. So for example, Findi can change these names and do more specific ones, but this is a trust over IP model, the generic one. So what we call here is trust tasks is a generic term for anything you can do between wallets within these ecosystems. And credential exchange is one of those. That the fact that you can issue a credential to a wallet and then prove that and verify that is just one type of trust task. So you could do different types of trust tasks, whether it's, let's say, verifiable media streaming, verifiable video conferencing, or let's say there would be another protocol that deals with exchange of consent information, or let's say would need to be a signal to open a door. So there are different types of protocols or trust tasks that need to be done. In some cases, they are very, let's say, feature rich, like let's say the credential exchange, or even going further, maybe even payments could be somewhere here if some banks want to do it within the connections. The point is that the layer 3 uses the connection and the wallet functionalities, whatever they may be. So they don't need to, in the trust task, they don't need to think about the connection or even the basic wallet functionality. They just focus on how the trust task works. And the same way, layer 4, the application ecosystems that may include health or supply or finance, it will build their own value chains based on the trust tasks that are available. So they may say that, yeah, we use the credential exchange to exchange identity information, or we use the we use let's say some kind of protocol to exchange payments between transitive payments between supply chains, or even ensure that sorry, health officials have permission to exchange data. It needs to be much more complex and progressive to do that than what we have right now. And those players in layer 2 for each ecosystem, you will have a lot of complexity again. And this is why trust over IP does what it does. And that's sort of the basic trust over IP model. And because things are never that simple and easy, let's shake that up. So the next, this is the, let's say, trust over IP version 1, the model version 1. I think Tarja linked to this already. There's a nice interactive version of this as well, which you can take a look at. And right now, what we're doing is we're working on the next version of this. And I want to talk a little bit about that and why it's important. And the point is that why is this all important is that as we have internet, for the internet, for example, we have an hourglass model that can be described, the hourglass model can be used to describe how the internet actually works. And you can see on the top level here, we have emails, interweb, our voice over IPs, what have you, the different applications that are using the internet. Then we have the protocols that these applications are using, which again use lower level protocols like TCP IPs, UDPs, etc. But they all support a single spanning layer, which is the Internet Protocol, IP. And because of this Internet Protocol, the applications above it don't need to worry about the applications below it, which are much more hardware focused. Like we have the Ethernets or the like just copper fiber cables and radio transmissions. So these are very segregated from each other on purpose. And on the top layers, they all need to focus on just supporting the needed lower level protocols that they want to support. So the IP layer is the actual cornerstone of the internet. So that enables us to make a bigger network, to enable global addressing. We all know IPv4 currently, the IP addresses, we've heard about that on IPv6. So that enables us really to scale the top part. And it also, what it does, why do we need a single internet protocol, is that it maximizes the interoperability. It enables for us to really enables us to create those interoperable applications like what we have here. And then it also maximizes the number of usable networks. So it's sort of like the least common network functionality. So it's about stripping everything to bare bones, to that most usefulness part, which is in this case Internet Protocol and the IP address, that then can be again divided into multiple layers. The layers above it can be divided into multiple layers that serve different needs. So when you go higher here, each of these protocols serve different needs. And we don't have that for trust. We've never had that. Internet has not had trust within it ever. So, and everything we've done on top of this is just, as I said, they're hacks. They're on the higher levels. They're on the email levels or the internet levels or even the HTTP levels, like HTTPS is the way we know right now when you have a secure web shop. Well, secure is in quotes, but that's sort of the thing. It's hacked into the higher levels, but we need to go deeper. And that's what Trust over IP version 2 is. It's about moving the current model so that it mimics the internet hourglass model and enables these new types of trust applications to be formed. And these are pretty much the same layers that you saw. We have trust support at the lower level, which is, again, the below the spanning layer. We have the trust spanning layer, which means basically the communication protocols, DITCOM, etc. Then we have trust tasks, which I mentioned, the different types of tasks like credential exchange and the application. So they don't change. So the model changes a little bit so that the utilities or the supporting functions like Findi are not at the layer 1 anymore, but they are actually right beside it because they have such a strong role in each of the layers. So they're not part of the hourglass per se, but a supporting layer to enable the hourglass. And these different other layers, what they then will be, what I can show actually in the next slide. So it changes a little bit. This is a technical slide, so I'm not going to take too much time. So things like the network transport protocols, different kinds of computing services are at the bottom. And the trust spanning layer is really about creating a single protocol that would enable the trust tasks to be formed, and so that enables the scalability above it. So this is where Trust over IP version 2.0 is going to. And so that's a really important example. And just one more slide, and then we can go into the assignments. And so the sphere of influence, so basically what Trust over IP is doing and what it's not doing. You can see the red here is the sphere of influence boundary for Trust over IP. So what we're doing is creating specifications and defining what are the requirements for each of these boxes and layers. And we're not really developing those. We may do some reference development, but very limited there. So we're more focused on creating specs. We're more focused on enabling standards to be formed. And then organizations like Findi Cooperative, or like that was mentioned, OP Financial Group, for example, is one of the banks that is currently building their own wallets. So they are the ones that will then start to work on applications or different types of task protocols that are required to enable those business services. And then the interoperability between the future chosen trust spanning protocol of Trust over IP, that and the other interaction protocols, that kind of interoperability is there as well. Utility services, et cetera, things like the Findi network, if there will be a network, and then other types of services that are not part of the Trust over IP scope, but are part of the solutions that actually provide those dependent or complementary services. So this is where it's going. So it's, again, a complex world. It's a really complex world, but using frameworks like Trust over IP, we can simplify that. We can talk about the trust tasks and the wallets and the connections as a much more simpler terminology once we get there. But really, it's a really good framework for your thinking on how does an SSI framework, or how does an SSI system works. So when I talk personally about SSI infrastructures, I talk about this whole shebang here. It's a big beast. And I trust that not everybody definitely gets everything of this, but just that you understand that there are different layers and they all add up to us having secure, private, trustworthy services that are easy to use, that give the control to the identity owner or the identity holder, and allow businesses to really create unique types of value chains and services for us. So I think that's exciting. And yeah, just to link some resources, I'm sure you will get these. So if you go to trustoverip.org, you find the Trust over IP model and the technical architecture, and then I've linked here the conceptual model I showed a little bit if you're interested in that as well. So you will get that.